Record it. All right, we're officially recording. Okay, so I've said this quite a bit that, one of the most important uses of calculus is finding maximum or minimum values. So like I said, for these, we'll be writing our own equations. So typically, the first thing, of course, after you read the problem, the first thing you should do is decide what it is that needs to be maximized or minimized, and then try to express that quantity in terms of one variable. You'll see what I'm talking about in a minute. And then we use the derivative to find the max or min, all right? Okay, so in this problem, we see the owner of a ranch has 3,000 yards of fencing to enclose a rectangular piece of grazing land along the straight portion of a river. He also wishes to subdivide the land by means of a fence running parallel to the sides. No fencing is required along the river. So the question is, what are the dimensions of the largest area that can be enclosed? So that's kind of our that's what we're trying to find. So we want to maximize the area is what we'll take away from that. All right. Now, it's always nice when they draw a picture for us, like it's done here. And they were even labeled. I'll put another X right there. So I guess the shorter, not necessarily, not that it has to be the shorter side, but the three parallel sides are X and the other side is Y. All right, so that's why I said, it's asking me to sign into something. Oh, sorry, hold on. I want to be able to save this. Gmail. Okay, please don't do that. Sorry. La la la. Oh my gosh. Okay, it's gonna let me save now. All right, I'm sorry. All right, so we want to maximize area. We have two variables, and that's why it says up there, try to express the quantity in terms of one variable, because unless you want to take some multivariable calculus, we need to just have one variable. Okay, so we're dealing with a rectangle here. All right, so it's a rectangle. We've got two things going on. We want to maximize area. Okay, so what's the formula for area of a rectangle? It's the length times the width. And then we're also dealing with the amount of fencing, or that would be like the linear amount of fencing. So what is he going to fence? Well, three sides of length X and one side of length Y. So the total amount of fencing is 3x plus y. And we're told that he has 3,000 yards. So the amount of fencing, we have a little equation, also involving x and y. So what I'm going to do next is solve that equation. You can solve it for either variable. I'm going to solve it for y because that's easier. All I have to do is just subtract 3x. So 3,000 minus 3x. And then, you know, this is the equation that we need to work with because that's the quantity that we want to maximize. So what I do from here is I take this expression that I just solved for y and substitute it in the area equation. Okay, so let me write that. Substitute 3,000 minus 3x for y in the area function. All right. Okay, so the area is x times y, but instead of y, I'm putting 3,000 minus 3x. And let's go ahead and remove the parentheses, make it easier to deal with. So it's 3,000x minus 3x squared. So that's the function that we want to maximize. All right, so now our calculus comes into play. Maximize the area, find the derivative. So a prime. All right, for 3,000x, the derivative is 3,000. And then for 3x squared, we multiply 2 times 3 is 6. Subtract 1 from the power gives me just x. And that's my derivative. All right, we set the derivative equal to 0. And I'm going to solve for x. I'll add the 6x to both sides, then divide by 6, which gives me x equals 500. Okay, now, okay, so basically, we want to, I mean, we're pretty sure that's the answer because there's only one, well, there's only one, actually it's not true. There are actually two things going on here. So we want the absolute maximum on the interval from 0 to 3,000. Okay, why 0 to 3,000? Well, x represents the length of the fence. So x can't be negative. And we only have 3,000 yards of fencing to begin with. All right, so we couldn't go over 3,000. So basically we're looking for the absolute max. 0, 500, and 3,000 are the choices. We want the maximum area, which was 3,000x minus 3x squared. And notice if x is 0, the area is 0. If x is 0, that means there's just one long fence along the river, and that's obviously not what is wanted. And then if x is 3,000, that's not even possible. That's going to give me a negative number. I don't know what it is. Because if x is 3,000, actually you've already gone over. You have 3 lengths of 3,000. That's not possible either. But that's not going to work. So it's going to have to be the 500. And let me substitute that in. Actually, I'm just going to go ahead and put it in y equals. So I can just go to my table. Okay, so when x is 500, the area is 750,000, and that sounds right to me. Okay, so now we've found our maximum. This is our absolute maximum. Let's go back, because this is a word problem. We need to be sure we answer the questions. What are the dimensions of the largest area, and what is the area? So we know x, which represents the 3 sides, and we know the maximum area. To answer all the questions, we also need to find y. All right, so y was 3,000 minus 3x and that's 1,500. Okay, so basically here's the picture of what's going on. We got 300 feet. I'm sorry, it's 500 feet. X is 500. And the longer side is 1,500. Okay, so when we say dimensions, the dimensions, that's the length by the width. So we would say it's the dimensions are 500 feet by 1,500 feet. The length and the width, it doesn't matter which one you call that. And then the maximum area is the 750,000 that I found when I substituted. Okay, so that's the answer. Is there any question about that? So far? Okay. If not, like I'm trying to remember that this one has a strange answer, but I don't remember what it is or how to fix it. So we'll just go with it. Okay, suppose a travel agency charges $300 for a certain tour when the tour group has 25 people, but will reduce the price by $10 per person for each additional person above the 25. What size tour group would give the travel agency maximum revenue. So again, from our calculus standpoint, we want to maximize revenue. All right. So how do they make their money? What do they do to make money? Well, they sell tickets. I guess we'll call it ticket for each person. So so the revenue is the number of people in the group times the price per person. All right. So what we know, for example, the charge is $300. $300 if the group has 25. Now, you know, if you just handed me this problem and said, hey, work this problem, I could probably work it without ever coming up with an equation or using calculus. You know, and I'm okay with that, because if our goal is to solve the problem, we use anything we can. So this is what I'm saying. So if they add one more person, so suppose they add another person, they have 26 people, now the price goes down to $290. All right. For 27 people, it goes down to $280. And you could actually multiply those together, you know, and just keep doing that until you found the maximum value. And that would be one way to work it. Like I said, it's, you know, it's not wrong, you know, if you're just trying to solve the problem. But if we look at this from a calculus standpoint and an algebra standpoint, first, we let X equal the number of additional people. All right. Then to get our revenue, so what did we do? Each time we added one person, we subtracted $10 from the 300. So algebraically, this is how I would write that. The number of extra people times $10 for each one, subtracted from 300. And then, like I said, we added one person, we added X people to 25. All right. So that's algebraically how you would write that. Okay. So are you with me? Actually, okay. Let's say number, I have this backwards. This should be, sorry, this should be the price. This should be the number. Let me do that. Okay, so this is the price per person, and this is the number of people. I mean, I just put the wrong numbers under the columns. Okay, sorry about that. So 300 for 25, it drops $10 for one more person, drops another $10 for an additional person. So if X is the number of additional people, that's our equation. Okay. And like I said, for a lot of people, that's the hardest part, is actually coming up with the equation. Now, we could use the product rule for that, or we could go ahead and multiply it all out. And then we can just, that's interesting. So I'm just using FOIL to multiply that out. So 300 times 25. All right. And then plus 300x minus 250x minus 10x squared is what I get when I multiply all that together. And then combining my like terms, I get 300 minus 250 is 50, 50x minus 10x squared. All right. So now we're ready to find where the maximum occurs. I'm going to find the derivative and set it equal to 0. So, of course, 7,500 is a constant, so its derivative is 0. For 50x, derivative is 50, and then 2 times 10 would be 20, and subtract 1 from the power. So, solving for x, and this is what I'm saying, when we solve for x, we get 2.5. So we can't have 2.5 people. All right, so that's why I said that I keep forgetting to change this one out. So 2.5 people is going to be 2 or 3 people. Let's see what happens. Let me go back. We want to be sure and answer the question. Let me add in here. This is the number of additional people. All right, so let's just work it out. If we have 2 people, that's 25 plus 2 additional people, and the revenue is reduced by 2 times 10. All right, if we have 3 additional people, the revenue is reduced by 3 times 10. So that's what, 27. 27 people times 280 is 7560, and then 28 times 270 is also 7560. So so we get the same answer either way. And like I said, we don't have a limit on the, it doesn't say we can only take so many people on the tour. I'm sure there is a limit, but they don't tell us what it is. So this is going to be our only option, other than no additional people. So the answer, either 27 with 2 additional people, that's going to be 27, or 28 people on the tour will give maximum revenue. Okay. Excuse me. All right, any questions on that one? Okay, so number 3 actually might be a little easier because you do have to come up with an equation, but not like the other. So this one says price per unit for Pilot V5 pens is P, given their P, where X is the number of pens sold. The cost for producing X pens is given. We want to know how many pens must be sold to maximize profit. What is the maximum profit, and what is the price per pen needed to maximize the profit? Okay, so it's all about the profit. Well, for profit, we need revenue minus cost. Well, they didn't give us the revenue function, but what they did give us is the price per unit. So we're going back to some formulas from the beginning of the course. The revenue is the price per unit times the number of units. So the price is actually this expression 50 minus 0.02x, and the number of units sold is x. Okay, so my revenue function turns out to be 50x times or minus 0.02x squared when I just distribute the distribute the x and remove the parentheses. Okay, so now I can find the profit. So pick up that revenue function that I just formed and subtract the cost function that I was given. Okay. Let's just call it P for profit. So now I need to go over and distribute the negative 500, negative 0.04x squared, and combine like terms. So 50x minus 500, and then negative 0.02 and negative 0.04 is negative 0.06 x squared. And that's my profit function. Okay. So again, to find the maximum, we need to find the derivative and set it equal to 0. So P prime for 50x, the derivative is 50. Well, minus 500 is a constant, its derivative is 0. And then for the next one, we keep the negative 0.06, and the derivative of x squared is 2x. So that's 50 minus 0.12x. This is another strange answer. Okay, so we'll set this equal to 0. I'll add the 0.12x to both sides. And then divide 50 divided by 0.12. is 416 and 6.6 repeating. Need to get some better problems. So we probably round that to 417. Technically, we'd need to see if it's 416 or 417 that would give the maximum profit. All right, so let's go back and remember, we've got to answer the question. X is the number of pins. The profit function we have, and then the price per pin, all of those are given to us. So let me get the price. It's 50 minus 0.02x. X is the number of pins. And then the profit, that's right at the top of my screen. That's the 50x minus 500 minus 0.06x squared. Okay, so is it 416? If it's 416 pins, let's see what happens. And if it's 417 pins, and that's just getting kind of technical, but it's okay. All right, so 50 minus 0.02 times 416 is $41.68. That's a little p. That's the price per pin. If it's 417, price becomes $41.66. And then the profit, again, I'll compute that for both numbers. I'm assuming y'all don't need to see my calculator. I'm just really just substituting in functions. All right, so for 416 pins, the profit is 9916.64. And for 417, well, it's a difference of 2 cents. It's 9916.66. So we make 2 cents more profit if we go with the 417, which, we'd be tempted to round that up anyway. But I just, since we have plenty of time, I thought I'd just go ahead and check both to see which is better, okay? That price, that's the price, okay? So that's it. There are only 3 questions. Does anyone have a question about any of these? I think there are only 3 problems in the homework, honestly, for this section. So, because I know these are harder, having to write your own equation and so forth. Any questions, anybody?
No, ma'am.
Thanks, Allison. Stop the record.